Hello everyone, myself Nikita Patil, Assistant Professor from Department of Information Technology. So today we are cover that is stacks in data structures. Okay, the contents will be what is stacks, stack representations, arithmetic expressions and evaluations. So what is stack? Stacks is a linear data structures where elements are stored in the FIFO format, that is last in first out principle, where the last element inserted will be the first element to be deleted. So basically the stack is the abstract data type that is popularly used in the most programming language. It is named as stack because it is the similar operations on the real world stacks. For example, like pack of cards or the pile of plates, the stack is considered for a complex data structures because it is used to data structures for implementation such as array, linked list, queues, etc. Now, how the stack will be represented? The stack will be represented in the different way, that is in the arrays also, linked list also, queue also. But stacks allows data operations at the one end only. At any given time, we can only access the top element of a stack. So following diagram will represent the stack representation. This diagram represent using the array because the array has the fixed size. We cannot recreate it. So the following diagram depicts the stacks and its operations. So at the top element we can insert also and we can remove also. So the stack can be implemented by the means of array structures, pointers and a linked list. Stack can be either be a fixed size or it may be a sum of dynamic resize. Here we are going to implement stack using the array, which means it is a fixed size stacks implementations. Now next will be that is arithmetic expressions and evaluation. So in any word or a group of word or a symbol that generates a value on evaluation, passing expressions means analyzing the expression for its words or a symbol depending upon the particular criteria. So in any expressions there is the two possibilities, that is the operand and the operators. So expression parsing is the term used in the programming language to evaluate arithmetic as well as the logical expressions. So the way to write arithmetic expression is known as notations. So arithmetic expressions can be written in the three different equivalent notations, that is without changing the essence or the output of an expression. So these are the three different notations. That is first one is the infix notation, second one is prefix notation, next one is postfix notations. These notations are named as how they use operators in the expressions. We shall learn the same year in this chapter. Now first one is the infix notations. Infix means that is we can express in the infix notation. For example, that is a minus b plus c, where operators are used in between the operands. So here are a, b and c are the operands and the minus and plus are the operators. It is easy for a human to read, write and speak in the infix notation, but the same does not go well with the computer device. So an algorithm to be implemented for the infix notations could be difficult and costly in terms of time and space. Now prefix notations, that operator is prefixed to the operators, that is operator is written ahead of operand. For example, that is plus of ab. This equation is to be in fixed notation, that is a plus b. So basically the prefix is before writing with the operand we can write the operators. Now next one is the postfix or notations. This notation style is known as a reverse Polish notations. These notation styles, the operator is postfixed to the operand. That is, the operator is written after the operands. For example, AB plus. So this is equivalent to the infix notations A plus B. So the following table will be different terms with three all these notations. So for in the first, that is we can see in the last in, that is A plus B, that is the output in the prefix and postfix, that is plus of AB and AB plus. Now second will be the with the different terms. Now for all these conditions we are see there is the parse expressions and there is the precedence as well as the assemblies. So as we have discussed, it is not a very difficult way to design an algorithms or the program to space infix notations. Instead, these infix notations are first covered into either postfix or into the prefix forms. Then we can compute all these with the infix form. So, parts and arithmetic expression, we need to take care of the operand, precedence and the associativity also. So, what is precedence? When an operand is in the between two different operators, which operators will take the operand first, it is decided by the precedence of an operators over the other. That is the priority based upon your arithmetics operators. That is a plus b into c. So here is the multiplication has the highest priority. So we will compute with the a multiplication b plus c. As multiplication operand has preceded over addition, b into c will be the evaluated first, then a table of the operators produced, that is the provides later. So what is associativity? That associativity describe the rules where operands with the same procedures appears in the expression. For example, the expression a plus b minus c both and plus and minus have the same procedure, then which part of the expressions will be evaluated first? So in determined by the associativity of the operators, here the plus and the minus are left associativity, so the expressions will be evaluated a plus b minus c. The table will be classified with, that is the priority as well as precedence and associativity. So here exponential has the highest precedence and has the right associativity. So every time the, if in the expressions, if there is the expectation, then there is the highest priority and it will be processed into the right associativity. Now the second term is, that is multiplication and division, has the second highest priority and it will be denoted into the left associativity. And the next one is, that is addition and subtraction, that is the lowest priority and it will be represented into the left associativity. The above table shows the difficult behavior of the operators, and any point of the time in an expression evaluation, the order can be altered by using the procedures. Okay, these are the some examples. In the next video, we are seeing the examples with how the infix value will be converted to the prefix and postfix forms. Thank you.